Hi everyone, and welcome to our first online video. Today we're going over section 2.9 on equations with several variables. Hopefully we get to meet in person again soon when this is all over, but for now we'll be doing these YouTube videos. So these equations in several variables, if they are part of a real-life application, they may also be referred to as formulas. Since we are still in chapter 2, unless stated otherwise, we're still assuming that the domain is still I. Now, occasionally, the problem itself will dictate a smaller subset than I. That varies from application to application. Again, that depends on if it's a real-world application problem, aka a formula. We're going to be solving these, and we don't have any new properties to solve these. These formulas, the equations in several variables, are solved using the same properties that we've been using throughout chapter 2. There aren't any new or different properties for equations in several variables. So we'll start with one that is an application in statistics. So we're going to solve the equation mu is equal to x minus z times sigma. Now here, one thing I can say is don't let the Greek letters intimidate you. They're just placeholders for numbers we don't know the value of, just like x is. And you'll be using a fair number of Greek letters in your stats classes. Now, right now, we have no idea what to solve for. If they want us to solve for mu, we're already done. So that is one new thing in the formulas that we haven't experienced before. They haven't had to tell us what to solve for. So for this one, we'll solve this time for just the x, since we're sort of used to solving for that. So as messy as this looks, this is really just a linear equation then, since we're going to treat all three of these other things as if they were just numbers. So our goal is to get x by itself. Whatever they tell us to solve for, that's our goal. Get that thing by itself. So first, I don't see x's on both sides. If I saw x's on both sides, I've got to fix that first before doing anything else. We don't have to worry about that on this first example. We'll get to those later. It looks like the only stuff that is on the same side as the x is being subtracted from the x. The inverse operation of subtraction is addition, so we'll use the addition property of equality to start us off on this. So on both sides, we're going to add z sigma. Again, that was by the addition property of equality. So left-hand side, I don't see any simplifying I can do. Unless I know something more about mu or z or sigma or all three, there's really nothing else we can do. We would do arithmetic on them, but we don't know their value. So we'll have to just take them as they are. So left-hand side stays the same. These two are additive inverses, so their sum is 0. That's the additive identity property again. And now we have something added to 0 by additive. Oh, my apologies, that was additive inverse, then additive identity. My apologies. So x is equal to mu plus z times sigma. After that, we would typically go to our solution set, but right now we don't know if this is in the set of integers or not in the set of integers. So we'll just keep it as is. X is mu plus z sigma. We know we're done when the only variable that we see on one side is the variable they asked for, and we don't see it anywhere else. I don't see any x's on the right-hand side. I don't see multiple x's on the left-hand side. So this one is done. This one we have solved for. They could give us the same thing and ask us to solve for a different variable, though. So this time we'll solve for z. So same equation, mu is equal to x minus z times sigma. So the goal is to get the z by itself. That means everything else has to move. Now think back to if you had a problem like 6 is equal to 5 minus, say, 3x. The first thing I would move here is the 5, whatever is added or subtracted before doing the multiplication property of equality. So we'll start with the addition property of equality, and we'll have a minus x on both sides. So that is, again, the addition property of equality. Left-hand side, nothing to do at the moment. Right-hand side, 0 minus z times sigma by the additive inverse property, additive identity property at bat and x. So mu minus x is opposite of z times sigma. So again, you want to periodically check in after you've finished each major step. What is our goal? Our goal is for z to be by itself. So that means everything on this side needs to move. Now really this is like having a negative 1z times sigma. We undo multiplication with division. So that's the multiplicative inverse. So negative 1 sigma, negative z sigma, divided by negative 1 sigma. So left-hand side, about the only change they would typically make is if you're dividing by negative 1, that really just flips your signs. So we would maybe likely see that as x minus mu instead of mu minus x divided by sigma. And then 1 times z on the right-hand side by the multiplicative inverse property. Multiplicative identity gets our z by itself. So z is x minus mu over sigma. So again, just keep an eye on what it is that they want by itself. All right, so I'm going to give you your own to try out, and basically what I'll be doing with these, instead of pausing for a set amount of time in the video, I'll just ask you to use the pause function on the video, try the problem out, and then once you're done trying it out, then go ahead and take a look at my solution. It's very important that you try these though. If you just watch it through, you're not getting as much out of it as you would if you were trying the problems. So this one we're going to solve for a. Yeah, we'll do a plus BC is worth D. And I'll give you the same equation again. This time you're going to solve for B. Okay, so go ahead and pause the video and we'll get back to it when you're done. Okay, welcome back. So our first one, my goal is to get A by itself. Again, if you want to think of a simpler problem, this would be equivalent to having x plus 5 times 3 is equal to 19 arbitrarily. So typically we would find a value for the 5 times 3 part. We don't know what B or C are worth, so we go ahead and skip that step and assume that, okay, I know whatever that value is. The next thing I would do is use the addition property of equality to move it. And that's exactly how we'll start this one. So I'll subtract BC on both sides. So left side I now have an A plus 0, right side I have D minus BC. Left side A plus 0 is worth A. That's the additive identity property. So A is D minus BC. Again, usually we would go to set notation, but we don't know really if this is an integer or not an integer. So we just leave it in this format. The second you try it problem, same equation, different variable, different goal in mind. So on this one, this would be more equivalent to having 7 plus x times 8 is worth, I don't know, 41. We would move the 7 first if our goal is to get x by itself. So we would move the a first, undo adding with subtracting. So I'll subtract a on both sides, giving me 0 plus bc is worth d minus a. 0 plus bc is still worth just bc, so bc is d minus a. Once I'm done with that step, again, I'll take a quick glance up here and remember what my goal is. My goal is to get b by itself, so that means that the c has to move. So multiplicative inverse. So 1 times b is worth d minus a over c. And multiplicative identity, 1 times b is the same as b. So b is d minus a all over c. My goal is to get b by itself. I have just a b on the left side, and I don't have any b's on the right side. So we know we're done with that one. Okay. So far, each variable that they asked for us to solve for, there was only one of in the problem. However, as you may have guessed, that's not always going to be the case. So this next one is a surface area problem, so it is a real formula. We'll just put a instead of s just because s's tend to look too much like 5s. So instead of SA, we'll just put A. A is 2LH plus 2WH. So again, multiple variables, they can't just say solve by itself. Solve for what? So this time we're going to solve this for H. So again, I'm going to sort of go to a pretend equation at the top here that's going to help me out with the more abstract example. So I'm going to leave the h alone. Everything else I'll turn into a number. Typically, we would get a number for this, get a number for that. We can't at the moment. We don't know what these things are worth. But we don't know after that we would try to combine those, and it's the distributive property that lets us combine those. So recall the distributive property, we have b plus c times a. That's the same as ba plus ca. And if you can start here and move that way, you can also start here and move back. So here they each have an h in common. We'll apply that distributive property. So I have 2L plus 2W. Each one of those was multiplied by an h. So here the h was acting how the a did in the formula. Okay, so now I have just a multiplication problem. I don't know what L and W are worth, but once I knew quantities for that, it would just be some number times h. I would undo that multiplication using division. That's my multiplicative inverse. So a divided by 2L plus 2W is worth 2L plus 2W in parentheses times h over 2L plus 2W. Even though we don't know the value, we'll assume these are non-zero. Any non-zero number divided by itself is a 1. So now I have a is a divided by 2L plus 2W is worth 1 times h. 1 times h is just h, so h is a divided by the quantity 2L plus 2W. All right, try another one. This one we're going to solve for just our plain old friend x again. Pi by ax plus b is worth cx. So a couple of new things are happening on this one. One, I noticed that I have parentheses at the start of the problem. Welcome back, our friend the distributive property again. So we'll go ahead and knock those down. So pi ax plus pi b is worth cx. So that's one of the things that made this problem look different than the others that we've done before. One other thing you might notice, the variable they want by itself, x, is on both sides. We definitely need it to be on the same side. One little tip on this one, since I have another term that doesn't involve x that's on the left side, I'm going to go ahead and move this other one that's on the left side. So I'm going to subtract pi ax on both sides, addition property of equality. So left side 0 plus pi b, right side cx minus pi ax. So I'm closer to my goal. I want the x by itself. I've got the x's at least onto the same side. Now we've turned it into this previous problem. Distributive property again. So left-hand side, additive identity, 0 plus any number is itself. So pi b on the left side. And on the right, that's c minus pi a. Close up the parentheses, each was multiplied by an x. So that's my distributive property. Now we have a multiplication problem involving our variable that we want by itself. So we'll undo that with division. We'll divide both sides by c minus pi a. So pi b over c minus pi a is worth 1 times x. A little heads up here, you may be tempted to try to cancel out those pi's. You can only do that if it's a factor. This was a factor. This was part of a multiplication problem, top and bottom. That I can turn into a 1. If it's a factor up here and part of just a term, not a factor of the entire denominator, I cannot touch it. I can't do any canceling. If you can't factor it, you can't cancel it in a fraction. But on the right-hand side, multiplicative identity, 1 times x is just x. So x is pi b over c minus pi a. Again, I know I'm done because the letter they asked for has one side and everything else is on the other side. And I don't have any of, in this case, the x's on the other side of my equation. All right. So I'll have you all do another, you try it. So again, I'll put the problem up, and once you've copied it, pause the video, give it a spin, and then play the video after you've attempted the problem. So this one I'm going to ask you to solve for t. So we'll do left side, 5 times the quantity pt minus q is worth m times t. So go ahead and pause that, play when you're ready. Welcome back. This one you might notice is very, very similar to our previous one. So I want to use the distributive property to start us off. Get rid of those parentheses. I want to simplify each side as much as I can before I do anything else. So 5pt minus 5q via the distributive property on the left. On the right, I still just have m times t. What I do after that depends on what they want by itself. They want t by itself, and I notice I've got t's on both sides. I've got to fix that. I need to get them on one side or the other. There's a very common mistake I see with people that try to move the mt, so I would recommend not moving the mt. I would move the thing that has something else on the same side. So I'll subtract 5pt on both sides. So left side, 0 minus 5q. Right side, I'll go ahead and use the distributive property and turn it into m minus 5p times t. So left side, addition or additive identity, negative 5q. Right side is still m minus 5p, close it on up, times t. Undo multiplication using division. We'll divide both sides by m minus 5p. So 1 times t is negative 5q over m minus 5p. Again, just like with the pi's, the 5's. If 5 is not a factor in the denominator, we can't cancel a 5. So 1 times t is just t. So t is negative 5 times q over m minus 5 times p. So we know we're done. We have the letter they asked for by itself, the variable they wanted by itself, and no copies of that variable on the other side. Okay, so that does it for our linears. On to our nonlinear friends from the section. So this next one, we're going to solve for another of our Greek letters, theta. So this will be a little practice with our rational equations. 1 over theta plus 5 over r is worth 6 over k. So again, what I do depends on what they want. They want theta by itself. Here we're going to assume that we are not breaking the division by 0 rule, so our excluded value is theta isn't 0, r isn't 0, k is also not 0. Our LCD would just be the product of those three. So we'll multiply both sides by the LCD. So I have 1 times theta rk over theta. plus 5 times theta rk over r is worth, don't forget to multiply both sides by the LCD, so 6 is also multiplied by theta rk, and we have k in the denominator. After that, we get rid of our 1s, so theta over theta is 1. So 1 times 1 rk is 1 rk. 5 theta k times 1 is plus 5 theta k. And k divided by k is 1. 1 times 6 is 6. 6 theta r. Again, after each major step, I recommend kind of glance up and think of your goal. So here our goal is to get theta by itself. I have thetas on both sides. So that means this guy I want to leave alone. I'd like to get them on the same side. So addition property of equality is up next. So 1 rk plus 5 theta k minus 5 theta k is 6 theta r minus 5 theta k. So left side, 1 times rk is rk, and we have r plus 0. Right side, I'll go ahead and use the distributive property. So 6r minus 5k, each one of them had a theta attached. So now I have rk is worth quantity 6r minus 5k times theta, and we finish it off as we have the last several problems. Multiplication property of equality. So rk is 6r minus 5 theta, and other side 1 times theta, so theta minus 5k, copying error there, my apologies, that is a k, not a theta. So theta is rk over 6r minus 5k. Since r is not a common factor in the denominator, I can't cancel it. Since k is not a common factor in the denominator, I can't cancel that either. This is as far as that problem will go. As part of your homework, I will have you solve that previous problem for k. Okay, we also have square root problems. So here we're going to solve for q. This one we're going to have to also make an assumption. So I'm going to assume that n is greater than or equal to r. So our equation, square root of px plus q plus r outside of the radical is equal to n. So square root problems. First thing we look for is the question, is the square root by itself? The answer to this at the moment is no, so we want to fix that before we do anything else. So that is our friend the addition property of equality coming back to help us out again. So square root of px plus q plus 0 is n minus r. So square root of px plus q is n minus r. Okay, so square root is by itself. After that, we looked at, okay, how do we undo a square root? Well, remember, square and square root are inverse operations. So I will square both sides. So left side square and square root will cancel, and I just have px plus q. Right side, to avoid a common error, you're going to go ahead and write out those two terms twice. And then we remember to FOIL that out. So left side, I'm going to bring that along, px plus q. Right side, FOIL it, n times n squared. Outside times outside, minus n times r. Inside times inside, minus n times r again. And last times last, negative times a negative is a positive, and r times r is r squared. So if px plus q is n squared minus 2 times n times r plus r squared. Okay, back up to the beginning. What is it they wanted? They wanted q. So it looks like q is pretty close to being by itself, but not completely yet. So I'll go ahead and subtract px on both sides. So 0 plus q is n squared minus 2 rn or nr, whichever order you choose, plus r squared minus px, and 0 plus q, of course, is q. So q is n squared minus 2nr plus r squared minus p times x. Q is by itself on one side, everything else is on the other side. All right. Next one will be sometimes just working with the formulas themselves. 1 second, I've got to fix my equipment here. It's about to fall. Okay, that's set pretty well. Okay. So this next formula is another actual word problem, real life formula that's used, and that is a Fahrenheit-Celsius relationship, temperature conversion. So it's an established relationship if you think of the freezing and boiling temperature relationship in water and the different scales. You can actually derive this formula for yourself using your Math 95 skills.